right, thanks everybody for coming. So I'll be giving an update on Scikit-learn, on what we added in 0.20 and what we're going to add in the future. So quick question here, who here uses like Scikit-learn on a regular basis? Okay, most people. So I'm going to do like a very brief overview, and then I'm kind of going to go through a laundry list of different features we added and what's the rationale behind these features and sort of what's important to us. Oh, there's a clicker. Wait. I want to see. Yes. All right. So what is Scikit-learn? Scikit-learn is a machine learning library in Python. So it implements lots of different machine learning algorithms for supervised and unsupervised learning mostly, together with tools to tune these algorithms, to build machine learning pipelines, and to evaluate algorithms. I'll go very briefly over the basic API. The data representation that Scikit-learn uses internally is always a NumPy array, which is usually a dense array of floats that we call capital X, where each row corresponds to one sample and each column corresponds to one feature. In supervised tasks, the target output for regression or classification is usually called lowercase y, and it's a one-dimensional NumPy array. So, while you can give Pandas data frames to basically everything in Scikit-learn, it will immediately convert it to a NumPy array, and so if you have like heterogeneous data types or column names or anything like that, Scikit-learn will mostly just completely ignore it. So the standard workflow in Scikit-learn for supervised learning is as follows. So all the models in Scikit-learn are implemented in Python classes, and these classes encapsulate both the training procedure and the prediction. So here, let's say I want to build a random forest model. I instantiate this CLF object, and this is when I would set any hyperparameters like how many trees I want in the forest and so on, and then I call fit on the training data, so this is representation of or the features, and this is the targets or the classification outcomes, and I call the fit method with both of these. This will build the random forest model and store the trees in a CLF object. If I want to make predictions using the model, I use the predict method and just give it my NumPy array of data. Most supervised models, or all of the supervised models, also have like convenience function to just score how well the model does on a new data set. This uses accuracy by default for classification, R² for regression. And internally, it just makes predictions and compares the predictions against the test set. I'm going to go through this pretty quickly because it seems you're all pretty familiar. So I mentioned the fit method. So all models in Scikit-learn have the fit method. We call the general like Python class or the API of this type of object estimator in Scikit-learn. So this could be any supervised or unsupervised model. They all have a fit method. They all get some data representation X, and for supervised models, they also get some target variable Y. Then there's two other methods that are really important. I mentioned already predict. Predict is if you want to predict some outcome or target variable in classification, regression, or clustering. And the other important method is transform, which is used whenever you want to create a new representation of your data. So basically, these create something like X. These create something like Y. These create something like a new X. So this is in pre-processing, dimensionality reduction, feature selection, and feature extraction. So this is sort of the basic model API. There's also a bunch of other tools, as I mentioned, to help you select models and build modeling pipelines. One of the most commonly used ones is Grid Search CV, which does parameter tuning using exhaustive search with nested cross-validation. Here's an example of how this might look like. This is sort of my hello world with Scikit-learn a little bit. So you have some data set given as X and Y. You split it into training test data set. You define a grid of parameters you want to search over. So here we're doing RBF support vector machine, RBF kernel support vector machine. For classification, there's two parameters we want to tune, C and gamma. So we specify this grid as a dictionary where the keys are the parameters we want to tune and the values are the values we want to try. And grid search will try all possible combinations of these parameters. The cool thing here is that, well, the cool thing is that this is all done automatically. The other cool thing is this grid object here, again, has the same estimator API as all the models. So this grid object, so this line actually only constructs the object, and then to run the grid search and to build the model, you actually call fit. Fit now runs the grid search with cross-validation, will select the best parameter settings, and will rebuild the model using the best parameters found on the whole training set. And then you can use this grid object just like any other classifier and call like score predict. So running this grid search looks exactly like applying any other model in terms of the methods you would use. The other tool that's very commonly used that's important in Scikit-learn is the pipelines. Pipelines allow you to chain several transformations with any arbitrary model. This is important to encapsulate like processing chains, in particular the pre-processing of your data. So here's an example. Say you have two transformations, say scaling your data and imputing missing values, and then you have a classifier. For pipelines, it's important that all steps are transformers. Apart from the last step can be anything. So if I call fit on this, what will happen is it takes your input data x and your targets y, fits the first transformer T1, say a scaling of your data, then uses T1 to transform your data to x1, say the scaled version of your data, then fits the second step, say imputation, call T2 here, then transforms x1 into x2, the imputed data, and then finally call fit on the classifier. So this kind of processing chains are very common, and basically anytime you apply any machine learning algorithm, you're likely to have this kind of processing chain. And then if you call predict, it will just call transform on all the things in sequence, and in the end call predict on the last model in a chain. This allows you to write very succinct code. It also allows you to encapsulate the whole processing within a single object, here this pipe object, that you can then easily store. So here's what this looks like in code. Just if I want to make a pipeline out of, say, scaling and support vector machine, the easiest way to do this is calling this make pipeline function. I give it the standard scaler, which does 0 mean unit variance, and the kernel support vector machine. And now this pipe object contains both of these steps. If I call fit, it'll scale the data, then fit the support vector machine on the scaled data. If I call predict, it'll scale the data, the test set, and then call predict on the scaled test set. I can also use this in grid search, which allows me to search the parameters of the model, but also of any pre-processing. So if I have like parameters in my pre-processing, like how many features to select or something like that, I can also search in the grid search over any parameters the pre-processing might have. The only thing you need to sort of take care of is that when you specify your grid of parameters to search over, you need to specify what step in the pipeline you want to adjust the parameters. So here, by default, the steps are named by the lowercase class names. So here I have an SVC, and I want to, again, adjust the parameters C and gamma. So I have to tell grid search to use SVC, which is the lowercase class name of the class I want to adjust, _C. And then it'll know to go to the step SVC in the pipeline and adjust C and gamma there. Cool. So who here has not seen this before? Everybody seen this? No, a couple. Okay. So this is what you should do every time you use Scikit-learn. And I'm not joking. Cool. That was just sort of a small refresher on sort of best practices and the tools that we have. Now I want to talk about 0.20.0. This is the current release that came out in October, I want to say. We will have a bug fix release 0.20.1, hopefully next week. So a lot of the things in this release are really about making things easier for users. So these are not like amazing new machine learning algorithms. These are tools to make the things that you do all the time as easy as possible. They're not as easy as possible yet, but I think we're moving in the right direction. So one of the things that I found endlessly annoying so far is that we couldn't use the OneHotEncoder, which does dummy encoding of variables on strings. Before it only worked in integers. Now it works on arbitrary Python objects, basically. So if you have data represented in this way, say a categorical variable that's male or female, and an integer variable 1, 3, 2, and you can call now OneHotEncoder, and it will encode both of these with dummy variables. And so that's kind of something that you really wanted, and it's kind of embarrassing we didn't have that before, but now we do. So that's good. Another thing that goes sort of hand in hand with this is the column transformer. The column transformer is the first time we really integrate with Pandas in a meaningful way. The column transformer allows you to apply different transformations to different columns in your data set. So usually you have at least 2 types of columns, say categorical and continuous variables. And you usually want to have different preprocessing for these different types of columns. So you want to have like different scaling, different imputation strategies, and so on. So here this is an example on the infamous Titanic data set. Let's say we focus on 5 features here. There's 2 continuous features or numeric features called age and fair, and 3 categorical features, embarked, sex, and p-class. And so now for the numeric features, I create a pipeline that says, oh, I want to do median imputation, then scale to 0 mean unit variance. And there's a syntax error. Damn it. So this will basically create a processing pipeline that's for the continuous variables. For the categorical variables, let's say I want to fill all the missing values with the string missing, and then I want to do a OneHotEncoder or dummy encoder. So now what the column transformer allows us is to use these on different subsets of the columns. So here I specify the columns. So numeric features are these guys. So these are column names in a Pandas data frame. Categorical features are these guys. Again, column names in a Pandas data frame. And these are the transformations I want to apply. So now these different preprocessing steps on the different columns are encoded in this preprocessor. And now I can build like a final model by putting this preprocessor in a pipeline with like some classifier. And so now the CLF object encodes the whole workflow, doing all the different encoding, scaling, and so on. And this is really helpful if you have different kinds of features in your data set or different columns that you want to treat differently. And yes, you can also specify, let's say if I want to use all the columns, I can just specify numeric features and then say what I want to do with the remainder. So by default, the remainder is to drop all the features that are not named, but I can also do something else with the remainder. Or I can say, these are the categorical features, do something with the categorical features, and the remainder are numeric, so just for the remainder, use a numeric transformer. Or just keep them as they are. Questions about this? And conceptually, it's pretty simple, but it's like, I think, a very useful tool. Sure.
Can you also handle date transformation in this?
Yeah, sure. You can do any type, but you need to declare what the transformation is you want to apply. Like you can use its function transformer to change your date to some format. And you need to specify more or less manually which columns you want to apply it to. We're working on sort of trying to make this more automatic to see which columns are which type. But the problem is if there's an integer column, there's basically no way to know if this is a continuous or categorical unless the user tells you to. Tells you which of the two it is. Cool. Going with the theme of like easier preprocessing, another thing that we added is the power transformer, which basically allows you to change the distribution of inputs in a flexible way. So the idea is if you have a skewed distribution as shown up here. Linear models in neural networks are often somewhat sensitive to the distribution of the data. We added in this power transform the Box-Cox transformation and Geo-Johnson transformation, which are both power transformations, meaning they take the data to some power lambda, and they estimate this lambda so that the data afterwards looks as Gaussian as possible. And so you can see these guys look sort of much more normal. This is a generalization of the trick of taking the log. So very often you, as preprocessing, might take the log of your data so that it's sort of scaled in a nicer way. This is a generalization that automatically finds out what is the right transformation you should apply in this family of power transformations. We also improved with missing value treatment in several ways. So we now allow passing missing values through all of the scalars. We have a new thing called the simple imputer, which replaces the previous imputer, which has like a slightly different interface. And we added a missing values indicator, which allows you to add additional binary indicators whether something was imputed or not. Usually data is not missing at random, so if you impute a missing value, you usually want to preserve the information that something was imputed. Because very often this is useful information. And so this missing indicator allows you to encode this. Even more preprocessing now of the target with the transform target regressor. This allows you to do a transformation, say log, to the target. So this power transformer was transforming your data. The transform target regressor allows you to do transformations on the target. So why would you want this? Let's say you have like a target that's skewed like this. You want to fit a linear model. If you log transform it, it might be easier to fit a linear model. But if you want to do something like model comparison, you want to do the model comparison on the original, in the original data space, right? So before you do any like computing the MSE or something like this, or here in this case the mean absolute error, you want to actually transform it back. And so this transform target regressor allows you to transform, say, into log space, then apply, say, a linear model, and then transform back for the evaluation. So then you can put this guy in a grid search, and it will do the right thing. If you just apply log to your y's, and then you do grid search, you will do grid search in the logarithmic space, which is usually not what you want to do. All right. Another thing, not related to preprocessing this time, that I'm very happy about is the OpenML Dataset Loader. OpenML is a platform that I'm done by some people in mostly in the Netherlands and Germany that I'm collaborating with. It hosts a bunch of different data sets. So right now there's about 20,000 different data sets there. It also allows you to specify machine learning tasks on these and uploads the results of different machine learning algorithms run on these data sets. And so they have like, I don't know, 8 million results. So this is cool. And there's like OpenML Python, which is a library that allows you to interface with this. But in Scikit-learn, we also want to interface with this just to get all the good data sets. So we added this function called fetch OpenML that allows you to fetch any data set that's on this platform by name. And you can, if you want your data sets to be easily available, you can upload your own data sets to OpenML, and then anyone that has Scikit-learn installed can get your data sets by just saying fetch and then the name. We previously had something like an interface to a similar platform called ML Data. The problem is that the person hosting ML Data doesn't respond to emails anymore, and the server is basically down. And so we're deprecating fetch ML Data, and we now have fetch OpenML. And the person that maintains this is now in my lab, and so I make sure that he actually maintains it. Another cool thing that we added, and this is really amazing work done by the team in Paris, is Loki. Loki is a replacement for the Python multiprocessing pool. So this is basically replacing a relatively low-level thing in Python to do parallelism. The problem was that this pool was not very stable, and we ran into a lot of issues with parallelism. In particular, on like Windows, you had to do if name equal main in all of your scripts if you want to use parallelism. And if you were on OS X, you might get random crashes because of the blast that Apple uses and how the people that write Python and the people that write Mac OS don't agree on what POSIX means. And if you have libraries using OpenMP, so if you're using like Keras or TensorFlow or XGBoost, they use OpenMP for parallelization. If you put this inside a Scikit-learn grid search and say njobs equal to 5 to do a grid search in parallel, before this would crash, now it runs. And so that's pretty nice. So another thing that we added is global configuration and working memory. So there's now a thing called the config context or set config, which allows you to set global flags in Scikit-learn. And two flags these are mostly for efficiency. So the two that we added so far is assume finite and working memory. I think assume finite we had already a little bit longer. Turns out that if you have a production system, if you call to predict on a model very often, the model is very fast. In Scikit-learn, most of the time is spent checking if the data is finite. And usually, if you have a production system, you know what the data is like. And if you say assume finite equal to true, it will not check if the data is finite. And sometimes that gives you like a 2x speed up or even more. Of course, if there's like a nan in the data, then it'll give you garbage or it'll give you nan as a result. The other thing that we just added is the working memory, which is mostly for if you want to compute big distance matrices or if you want to compute nearest neighbors between many samples. If you have like 1 million data points and you want to compute the 3 nearest neighbors, you like theoretically want to compute a 1,000,000 by 1,000,000 distance matrix, but that might kill your RAM. And so this working memory tells you don't use more RAM than this, and so it will chunk big computations into smaller pieces so that basically your machine doesn't start swapping. And so right now it's like the default is 1 gigabyte, but you can set it to more if you want. And so basically this way you can do chunking that's appropriate to the memory you have. This is right now mostly used in distance computations, but it's probably going to be used more widely in Scikit-learn in the future. The reason why we need this is because it's very hard to actually detect automatically if your RAM is getting full. So it's basically impossible for us to detect whether your RAM is getting full, and so we need you to tell us in advance how much RAM we're supposed to take. A couple other efficiency improvements. Gradient boosting classifier now has early stopping, which means that you can specify a validation fraction. It will hold out a validation set, and then it will stop adding more trees when the validation set score doesn't improve. And the same thing for stochastic gradient descent and all the similar models where you have like a validation fraction, and this allows you to do early stopping on a validation set. Another thing that I think will be great for users is that we added a glossary, which is basically a page in documentation that says, explains what we mean when we say words. So there's a lot of slang we use in Scikit-learn, and this explains all the slang, hopefully. If something's missing, let us know, then we'll add it. And all of our documentation, we're now linking to this glossary to explain all the different things that we, like what the words mean. We also changed some defaults, though I don't want to like go over these in too much detail. You might notice that if you upgrade, you see a bunch of deprecation warnings, and I want to talk about this in a little bit. So the thing is that a lot of people are using Scikit-learn, and a lot of people are using Scikit-learn in production, and so if we change the behavior, the behavior of your production code will change. Most people don't like that. So what we do is we basically have a contract with our users that says we will never change our code without warning you first. So whenever you have any Scikit-learn code, it will do exactly the same thing in the next version, unless it warns you that it's not going to do that. And we'll always warn the user for 2 versions, which should give you 1 or 2 years, depending on how slow we are with releases, to adjust your code. So for most users, these deprecation warnings are like a little bit annoying, but if you have a production system running, they're really important because they tell you you need to change your code now, or either the behavior will change or the code will break. And so the alternative to doing these deprecation warnings would be to immediately change the behavior or immediately break the code, or not to do either of them, never change anything. I don't think either of these options are very good, and so we do this like deprecation cycle, which usually takes like a year or two versions of Scikit-learn. And yeah, so as an end user, usually it's relatively fair to ignore those unless you have code that you need to have been running. So like if you have experiments that you possibly want to run again in a year, you need to make sure you address these warnings, because otherwise the code might stop working in a year. And like one of the things, maybe I'll go back to this, is, for example, we used by default cross-validation used to be 3-fold cross-validation. If you didn't specify, it will be 5-fold cross-validation in the future, because no one should use 3-fold cross-validation, and 5-fold is like a more accepted default. And so we want to change this, but we are not going to change this now. We're going to yell at you for 2 versions if you didn't specify which cross-validation you wanted. And in 2 versions, in 0.22, we're going to switch the behavior. And similarly for random forests, right now the default is to have 10 trees in the random forest, which makes no sense at all to me. And so we'll change this behavior to 100, but we're not going to change this now, because we don't want to break your code if you, for whatever reason, wanted to use 10. And so we'll yell at you if you use the default for 2 versions, and then in 2 versions we'll change it to 100. Cool. So these were all the features that are in the already released version. I'm going to talk a little bit more about things that are coming up. So first, things that we already merged into master. So these will definitely be in the next release. And then a couple of things that are work in progress that will hopefully be in the next release. And by release, I mean 0.21, not 0.20.1. So that will be in the next major release in like half a year, not in the release next week. So one thing that I'm excited about, because I wrote it, is we have new visualization for trees. So one of the nice things about decision trees is that you can easily plot them. Unfortunately, the easily so far was a little bit hindered by a reliance on a library called GraphWidth to lay out the trees. That's very hard to install on lots of operation systems. And so now we basically wrote our own visualization, or rather I copy and pasted it from Stack Overflow. And so we can just use Matplotlib, and we don't have to rely on GraphWidth, which is like a weirdly packaged C library. So other things that we work on right now, particularly for the first time ever, there's a draft roadmap. So right now it's a draft. We're going to publish sort of a final version or a consensus version on the website pretty soon. You can already check it out in the wiki. This is all the things we want to work on, like longer term. So because there's like a lot of things going on, and we have thousands of open issues, or at least 1,000 open issues, and it's very hard to track. And so this is sort of trying to give a big picture overview of what's happening with Scikit-learn these days, and what will happen in like the year or 2 years to come. So one of the things that will happen is that we're dropping Python 2.7 support in the next release. Actually, Matplotlib already dropped Python 2.7 support, and NumPy will stop adding features for the Python 2 release at the end of the year. So now is really a good time to go to Python 3. We are also dropping Python 3.4 support, so you should really work on Python 3.5 at least. Otherwise, all your libraries will not work anymore soon, or at least you will not get updates with the new features. So if you work at a company and you're running Python 2, tell them it's a very bad idea. Another thing that I kind of like and excited about, even though it's like not a big machine learning thing, is we are working on a new representation, a new Dataset Wrapper. This is what you get in your Jupyter notebook if you like write a model. It'll print out some text. If you have like a pretty standard thing like a grid search object here with the pipeline, this is actually the example I gave you earlier, like doing grid search with a pipeline with a standard scaler. If you look at this now, it'll print this. I don't think this is very pretty. In particular, the indentation makes no sense. It's been this way since I joined Scikit-learn like 7 years ago, and I didn't like it then, I didn't like it now. So I told my postdoc to fix it. So this is what it looks like now. And now it's like still a whole bunch of text that's like possibly a little bit hard to see all of them because it plots all the parameters, but at least the indentation makes sense, and you can see there's a grid search object, there's a pipeline object in it, and it has steps, and these are the 2 steps. And so I think that makes much more sense than this, which made no sense at all. But then we even went a step further, and using the new configuration context, or you can also use setConfig if you want to globally change it, we can say print only the changed parameters, and then the representation will be this. And so here, this is actually very compact, and you can actually see what this is supposed to mean, instead of like totally overwhelming you with all of the implementation details. So this is what we had before. This is what we're going to have then. And hopefully, this will be like less scary and will actually tell you something about the models you're working with.
Yeah, for sure. I mean, we'd be helping you throughout.
Again, this is more on this theme of like trying to make it accessible, trying to make it user-friendly, and yeah, really making easy tasks easy. Another thing that we're working on is, I already mentioned Loki, which is this new processing tool, multi-processing pool developed by the team in Paris. This will allow us to do more fine-grained parallelism. So right now, Scikit-learn only does parallelism on a very coarse scale. So for example, in random forest, it will build each tree on a different core. This is one of the reasons our gradient boosting is so slow, because we can't build a single tree across multiple cores. We can't do fine-grained parallelism right now because of the way how Python multiprocessing works. With this new processing tool thing, we'll be able to use OpenMP, and we're right now trying to add this to k-means, but hopefully we can add this to basically all models and have Scikit-learn be like a true multi-core library, which unfortunately it does not right now, or not as much as we would like. Another thing that we'll integrate is there's a library called Inbalance Learn, which allows you to resample data sets. For technical reasons or for API reasons, right now you can't easily resample data sets in pipelines, and basically we will integrate the API from this library Inbalance Learn in some way, and this will allow us to do subsampling and oversampling of data inside pipelines, which will be nice. How many? Doesn't tell me how many slides I have. Oh, 2. Good. And the final new feature that I'm working on right now is basically integrate even better with Pandas. So I talked about this column transformer that allows you to apply different transformations to different subsets of the data. The problem is, once you fit a model, say I do my pre-processing here, and then maybe I do some logistic regression or something. I want to get my coefficients out. I want to know what the coefficients mean. Right now, there's no way for this thing to tell you what what thing in the original data the coefficient corresponds to. So I want to really get this get feature names thing, which works in some places in Scikit-learn but won't work here, which will tell you, well, the first feature is this thing, the second feature is this thing, and so on. So you get the correspondence, you get the semantics of where do these features come from, what do these coefficients mean. Yeah, because right now, basically, this column transformer is very black box, and pipelines similarly are very black box, and it's very hard to see what do these different features in the model actually mean. All right, so this is all I had for today. This is a book I wrote with Sarah Guido. If you're interested in learning more about Scikit-learn, you can check it out. It has no formulas in it, only code. That was sort of my goal with this, is this really targeted programmers. If you want something more advanced, there's also the lecture I'm giving here at Columbia, Applied Machine Learning, is on my Columbia website with like, I don't know, 20 videos or something of me talking about Scikit-learn and other machine learning stuff.